Okay, so this is a second part of our lecture series on types of language models. So basically, when we talk about language models, uh, we primarily distinguish language models into two types. One is probabilistic models or statistical models, and the second one is neural network based modern language models. The probabilistic models are statistical models that can predict the next word in a sequence based on previous word. Some of the popular statistical models are Gengram Model, Bidirectional Model, Exponential Model, and Continuous Space Models. So let's talk about Gengram Model. So basically, Gengram Model, uh, so it is one of the simplest approach to language modeling. Here we create a probability distribution for a sequence with a size n. For example, if n equals 4, we consider 4 words in a sequence to be considered in the context while training our model. A 4 gram of word, a 4 gram of word may look like this. Can you help me? In this case, we assign a probability to sequence of 4 words. Then we have a Unigram model, similarly bigram model and trigram models. So Unigram model is the simplest type of language model. This model does not look at any conditioning or any conditioning. So that means to say any conditioning context. So that means to say it evaluates each word or term independently. Similarly, there are bigram and trigram models. Like bigram based on probability of one word is based on probability of previous word, and trigram based on if the probability of one word based on probability of next and next, or previous and previous two subsequent words. So this is trigram. So next thing we would like to talk about is bidirectional statistical models or bidirectional language models. So basically N-gram models only analyze text in one direction. Thus this can reduce model accuracy. So bidirectional model can overcome this limitation. These models are capable of analyzing text in forward as well as in a reverse direction. So a typical example is of Google. Google uses a bidirectional model to process each search queries. Okay, so exponential models evaluate text by combining n-grams and along with feature functions. The goal is to minimize the energy. The goal is to minimize the energy and maximize entropy. In this case, the features and parameters of the desired results are already specified. So what the principle of entropy states is that probability distribution with maximum entropy results in the best performance. Probability distribution with maximum entropy results in best performance. So these models are commonly used in classification tasks such as take an observation, extract some features. For example, take an observation, extract some features, combine them linearly, multiply each weight and add them up using sum of exponent, and classify each into one of the set of discrete classes. As it is probabilistic classifier, it gives the probability of observation being into that class. Here is an, for example, we can say that uh, we can we can find an example such as example of tagging. A feature for tagging might be this words end in ing and the previous word was the. then then probability of c given x equal to 1 upon z, exponents of summation from I with weight vector wi and feature vector fi. So the next we are talking about continuous space statistical model. In this approach, we arrange words as non-linear combination of weights in neural network. So we arrange words as non-linear combination of weights in neural network. As an example of non-linear combination of vector is, so given x1 y1 z1 and x2 y2 z2, then the non-linear combination is y1 z2 z1 x2 x1 y2, while the linear combination may be like x1 x2 y1 y2 and z1 z2. So as we know that the process of assigning words to word is called as word embedding, and these models are helpful in the scenarios where the data set of words continuously grow larger and include unique words. So in those cases, continuous space statistical models might be helpful. So linear models such as Gengram does not work with these use cases where we have large data set and that consist of unique and rarely used words. So this is because with increasing words, possible word sequences increase. So the pattern to predict a next word becomes weaker. This limitation is overcome by the continuous space models. So basically, so why continuous space models perform better than Gengram models is because of the scenario as like that. So next we would like to talk about neural language models. So neural language models are based on neural networks. We can say that these are the advanced approach to execute NLP tasks. These models overcome the limitations of classical models such as Gengram and are used for complex tasks such as machine translation or speech recognition. Some of the popular neural language model architectures are recurrent neural network, LSTM, GRU, transformer, and so on.